Hello friends, this video on Binomial Theorem Part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched Binomial Theorem Part 1 to Part 7. We'll take one more example that is a little tricky. So we have to prove that 6 to the power n minus 5n leaves a remainder 1 when divided by 25. So that means if you read this you mean to say that 6 to the power n minus 5n, this is nothing but 25k plus 1. That means when you multiply 25 with some number and you add 1, you get this. Or when you divide this by 25, you get k plus 1. So this is the mathematical representation when you say when this 6 to the power 5 minus 6 to the power n minus 5n is divided by 25, you get 1 as remainder. So we can write 6 to the power n minus 5n is equal to 25k plus 1. So this is what the question is saying. Now we have to prove this. How can we prove this? We don't have any clue. We can see it is 6 to the power n. So that means this is a question of binomial theorem. Now we can write 6 to the power n as 1 plus 5 to the power n. We can also say 7 minus 1 to the power n. Any form we can write. But now when we see that we have somewhere 25 and 5, that is 5 is equal to 5 to the power 1, 1 is equal to 5 to the power 0, and 25 is equal to 5 to the power 2. So it will be good if we break this 6 to the power n in terms of 5. Going by the question, just by the gut feeling, I felt that this is 25, this is 5, this is 1, and all our powers are 5, for 5 to the power 0, 5 to the power 1, 5 to the power 2. Just by gut feeling, I'll write this 6 to the power n as 5 plus 1 to the power n. So I'll say 5 plus 1 to the power n minus 5n. This is my LHS. So I'll take the LHS, I'll expand this because I know how to expand 5 plus 1 to the power n, and I'll see what I get. So I'll say 5 plus 1 to the power n. This we can say 5 plus 1 as n C0 into 1 to the power n plus 5 to the power 0 plus nc0 will decrease the power of 1 to the power n minus 1 into 5 to the power 1 plus nc2 into 1 to the power n minus 2 into 5 square dot ncn 1 to the power 0 into 5 to the power n. So we'll ignore 1 to the power n part because always 1. So this becomes nc0 is equal to 1 into 1 into 5 to the power 0 is equal to 1. This is 1 plus nc0 is n into 1 to the power n is equal to 1 into 5 plus what you get nc2 is, we'll write nc2 only, into 5 square plus nc3 into 5 cube dot ncn into 5 to the power n. So if we observe this, and this is the expansion of this, to subtract minus 5n here, correct? So here also from this we have to subtract 5n because we are talking about LHS. LHS is equal to this minus this. So you see 5n is gone here. So what you get 1 plus, and here we see 5 square we take common 25. So if we take 25 common, so this becomes nc2 plus nc3 into 5 plus nc4 into 5 square dot ncn into 5 to the power n minus 2. Why? Because we have taken 5 square common. This is 5 square. So 5 square, 5 to the power 2 plus 5 to the power n minus 2 is equal to 5 to the power n. We can also write this whole thing as a constant. So this becomes 1 plus 25k. So our LHS become 25k, 1 plus 25k, and that is what our LHS was. So we have to prove that this was equal to this, and we have proved that 5 plus 1 to the power n minus 5 to the power n, that is 6 plus n minus 5n, this is equal to 25k plus 1. That is, when you divide this number by 25, you get 1 as remainder. That's what we have to prove, and we have proved that. Let's take one example which is medium level. Here we have to find a plus b to the power 4 minus a minus b to the power 4, and then we have to evaluate this. So we have to do this using binomial theorem. We know how to expand a plus b to the power 4, and we know how to expand a minus b to the power 4. So let's do this. Let's take this part first. So the a plus b to the power 4 we can say as 4c0 a to the power 4 b to the power 0 plus 4c1 a to the power 3 b to the power 1 plus 4c2 a to the power will decrease to b to the power 2 plus 4c3, this becomes e to the power 3, this is 2 and 2, sorry, and this becomes b to the power 1, 2, this becomes 3, and this becomes 1 because we are decreasing the power of a, plus 4c4 a to the power 0 b to the power 4. This is the expansion of this. We will say minus. I'll take this whole bracket now, this also bracket. So I'll expand this now. So a minus b to the power 4, this becomes 4c0 a to the power 4 plus 4c1 a to the power 3 minus b to the power 1 plus 4c2 a to the power 2 minus b to the power 2 plus 4c3 a to the power 1 minus b to the power 3 plus 4c4 a to the power 0 and minus b to the power 4. So for all the powers, even powers, that will become positive and all powers become negative. So if you see b to the power minus b to the power 1 becomes minus b. So I'll write this. So I'm subtracting this. So what I get is I can subtract these two, same. I can subtract these two also because minus b to the power 2 is equal to b square. So these two are same. Similarly, these two are also same. So what I get is when I subtract this from minus b, so this I get 2 into 4c1 a3b plus 2 into 4c3 ab3. This is the thing we get. Or I can also say 4c1 is equal to 4, so I'll say 8ab into a square plus b square. Same thing I wrote, 2 into 4c1 is equal to 8, ab I took common, so this becomes 8 square plus b square. So I can say the formula of this a plus b to the power 4 minus a minus b to the power 4 is nothing but 8ab into a square plus b square. Now we have to, when I say root 3 plus root 2 to the power 4 minus root 3 minus root 2 to the power 4, I am replacing a by root 3 and b by root 2. So what I get, a into a is equal to root 3, b is equal to root 2 into root 3 whole square plus root 2 whole square. So what I get is 8 root 6 into root 3 whole square is 3, root 2 whole square is 2, that is 8 into 5, that is 40 root 6, and this is the answer. So what I have done, I have expanded a plus b to the power 4 and a minus b to the power 4, subtracted the thing, and I got this, and then I replaced a and b with root 3 and root 2 respectively to get the answer. Let's find general term of expansion a plus b to the power n. General term is represented by tr plus 1 is equal to ncr a to the power n minus r b to the power r. So we can see this, if we expand a plus b to the power n, so I'll say a plus b to the power n, what I get is nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2 dot 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 ncn a to the power 0 b to the power n. This is the formula we have already studied. So we know this is the first term, this is the second term, this is the third term, and this is the n plus 1 term because they are n plus 1 terms in the series. Now when I say in this case t r is equal to 0, I get t1 is equal to nc0 a to the power n minus r is equal to n minus 0, 0 and b to the power 0. This is similar to first term. In the same equation, if I say t2, r is equal to 1 I have to put, because 1 plus 1 is equal to 2. So I have to say r is equal to 1, nc1, a to the power n minus 1, b to the power 1. So if you see t2 is same as this term and this term are same. Similarly, when I say t3, I have to say t2 plus 1 actually. That is equal to t3. So r is equal to 2 we have to put. So I have to say nc2 a to the power n minus 2 b to the power 2. So if you see, this term is equal to this term in the circle. This term in the circle is same. Similarly, when I say tn plus 1 term, so I will say tn plus 1. So here I have to say r is equal to n, because I am looking for n plus 1 term. So this becomes ncn, because r is equal to n, a to the power n minus 1 0, b to the power n. So if you see, this term in the zigzag is same as this term. So what we have seen that if you expand this formula holds true. So please remember this formula: t of r plus 1 is equal to ncr into a to the power n minus r b to the power r. Here this is t r plus 1th term. This is not about t r term. This is t r plus 1th term. So when you want first term, you have to put r is equal to 0. So t1 will be equal to r is equal to 0, nc0, 0, a to the power n minus 0, b to the power 0. When you want to find second term, you have to put r is equal to 1. So t2 will become nc r is equal to 1, that is nc1, a to the power n minus 1, b to the power 1. So this is the formula. Please remember this formula. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.